So now it's time to finish up Chapter 7 with the easiest section in the entire course. You're welcome. I'm here to help. So the thing about Chapter 7, and honestly, Chapter 8, Chapter 9, Chapter 10, 11, 12, 13, 14, is that they all require that you're working with normal data. It's typical in an introductory statistics course for that to be a requirement. The normal distribution is a pretty powerful distribution. For example, we have these qualities here, norm dist, norm inverse, these very powerful functions, but you can't use them unless you know your data is normal. Well, that's not going to be that big of a problem for us most of the time, but sometimes we want to double check. We want a way to make sure that our data is normal. And there are a variety of ways to do that, but in this level, of course, what we're going to look at is a normal probability plot. And it's a plot of points, namely the points that are from your data set. For example, these data points are put here. So for example, 20s here and so on. And I'm not going to get into how this is created. It's created with percentiles and quartiles, but suffice to say, we don't need to know how it's made. We just need to know how to look at it. And according to this, it'll say that the sample data is taken from a population that is normally distributed if a normal probability plot of the observed values versus the expected z-scores will be approximately linear. In other words, do these points basically follow that center line or not? This particular program that I'm making it with is called Minitab, which is not a program you have, but for this program you want to see if it's inside these boundaries right here. Okay, which it is. So this data is normal as far as we can tell. You actually want it to be normal with no outliers, but a box plot would be a better measure of outliers. All right, now look at this data. See all these points outside of those boundaries? That data is not normal. Okay, if any one of those had been outside, like just this point had been outside, it's not normal. Because you want it to be normal with no outliers, you want it to follow that linear pattern, you want it to be between those boundary lines. So the only way I can make this more interesting is I could make it so you have to do it. Make your own normal probability plot, which is not difficult to do. It's very difficult in Excel, but we're not going to use Excel. We are going to use StatCrunch. Now remember, StatCrunch is available, oops, here it is. It's available under the Tools for Success. There it is, StatCrunch. You can click there, which I already did, and that brought, oh, it disappeared now. There it is. I'll bring it up again. And then there it is, StatCrunch. And you can type in the numbers from your particular data set. So let me go over here. Of course, if you're working in my math lab, it'll give you that option to copy to the clipboard and so on. But here I'm working from notes, so I'll have to type it in my own self. There we go. And then I'm going to go to graphics, and you're going to pick the QQ plot. That's the one. It stands for, I believe, quantile. And then you select your variable, like mine's variable 1, or if you've given it a name, then so on. And you can create graph, and there it is. And so then you say, okay, do these points more or less follow along that line? If they do, in other words, are any points really far away? You know, something over here, or something over here, or something over here. And we don't have any of those, so I'm just going to copy, and I'll go back to my notes, and paste, and there's the graph. And so these data, the points are close enough, they're close-ish to the line. So data appears to be normal as the points are all following along the line. That's it. That's all there is to it. We are done with Chapter 7. I'm not going to cover 7.5, and you do not have to do it for the course or in the homework. So I hope you enjoy it, and I will see you here again on the YouTube channel for Chapter 8. Bye.